All right, well, maybe we'll get started here. Well, again, welcome everyone to the RCR Wireless News, breaking down the 5G feature webinar. I am Dan Meyer, Editor-in-Chief here at RCR Wireless News, and I'll be the moderator for today's webinar. Today we'll be discussing the broad topic of 5G. This is obviously a very large topic at the moment, as there's not, sorry, got distracted there, not yet a real standard for 5G, but along with our panel members, we will look at where the industry is today in terms of the move towards 5G. So this will include progress in terms of standards work, what panel members think will be included in those standards, some of the use cases and need for 5G, what role spectrum will play in the process, and the role of 4G LTE in the new 5G world. Joining me today to provide insight into these topics are a wide range of experts, including Bill Ho from 556 Ventures, who will provide analyst overview of some of the topics, Guenther Ottendorfer, who's from Sprint, to provide a carrier perspective, including some of Sprint's work in the space, Michael Murphy from Nokia to provide some technical background on 5G, Dugar Maladi from Qualcomm to provide some insight into the new radio aspect of 5G, and Ian Wong from National Instruments to discuss some of the recent work on 5G technology. The plan is to leave the final 15 minutes or so of the webinar for Q&A for those of you who are listening in on the webinar. Please feel free during the webinar to send those questions along using the questions, the Q&A tab there in the control panel. If you have a question for a specific member of the panel, please make sure to include their name in the question as well, and we'll try to get those directed in the right direction there. For those of you who might be having some audio difficulties, we will try to speak as loudly as possible, but please make sure to check your audio settings as well. All right, well, here's just a quick slide to kind of give some background on RCR Wireless News. We've been covering the mobile space for more than 30 years and have a lengthy history of covering the wireless ecosystem dating back to the 1G days before it was even known as 1G. All right. So I want to start and just give a quick overview on the 5G space, tapping into some findings from a new report we are releasing today that is available now or should be available shortly here on our website. Since we have such a prominent panel, I will quickly zoom through some slides here. But for those that want to take a longer look at the slides, we will have a replay of this webinar on our site shortly after its conclusion here that should allow for longer looks at the slides. All right. So let's start off with, I guess, what is 5G? That's kind of the question of the day, really, or maybe of the past few months. Obviously, there are standards bodies that are involved in this, and you know, some of the conclusions people we've been speaking with in terms of the topic, you know, some of the standards definitions, you know, people are looking at least 10 gigabit per second speeds, latency of less than 1 millisecond, very broad spectrum support, new antenna technologies, maybe even a new air interface. So a lot of things are up for discussion in terms of what 5G will be. That's still being worked on, obviously, through various standards bodies, but that's kind of the basics right now of what we see moving down that road. And of course, there are always the marketing departments what they think 5G will be, and obviously it's always something better. So we'll see what happens there. Why do we need 5G? So obviously the use cases is a big part of this. Some of the initial plans for 5G seem to be focused on enhanceable broadband or fixed wireless deployments. I think some of the carriers out there have already announced that's kind of their initial plans for what they call 5G. Obviously, ultra reliable, low latency for industrial healthcare and transportation safety as well is being talked about. Massive machine-to-machine or IoT connectivity in terms of connecting billions of devices to networks. A lot more complexity than networks, and obviously managing that complexity will be a big part of what 5G is going to be. What role does spectrum play in 5G? Obviously, it does seem like that in terms of what people are talking about for 5G, there will be a lot greater need for broader and wider spectrum bands than what we see today in 4G and 3G networks. So there's a lot of talk about using broad spectrum from almost anywhere, low, mid, and high band. There is some ongoing 600 megahertz auctions here in the US that's been talked about for 5G use. There's a 3.5 gig band that's being talked about for shared use in the market. And obviously millimeter wave spectrum is a big part of this as well. Spectrum above the 6 gigahertz band, which is not a traditional use that we've seen in the past, but it's been talked about a lot for 5G. Also a lot of discussion about unlicensed spectrum. There's a lot of technologies out there being used and trialed that'll allow perhaps for greater use of unlicensed spectrum for support of 5G services. And again, it's basically just looking wherever we can for spectrum to support 5G services. Also some potential for operators to refarm their current spectrum holdings. I know a lot of operators are already refarming some of their 2G and even 3G spectrum for 4G services. And so it's expected that that'll continue in terms of 5G support as well. One challenge will always be in terms of the international harmonization for spectrum. That's something that's always been worked on in terms of trying to get as many countries as possible to agree to using certain bands, which helps out the vendor community out there. So far, we're pretty early in this process. It's still looking like a bit of a challenge. I know the U.S. Is perhaps going in maybe a different direction in terms of some spectrum bands, but there's a hope that there will be at least a few bands that will be used around the world in terms of 5G networks. And there's also the role of what 4G LTE will play in terms of 5G. At least here in the US, there's a very broad deployment of 4G LTE services out there, and most developed worlds as well. And those networks required a lot of investment from operators who are looking to, again, continue to generate revenue from those networks. And those networks also use, a lot of them are using lower band spectrum, which could be a great coverage support for the millimeter wave, which is expected to be used for 5G. And one thing too is, and this came from the recent CCA show I attended, where rural carriers were discussing the fact that they're still in the midst of their LTE rollouts and would like to maybe catch their financial breath in terms of continued rollout of technology. So it does seem like 4G is not going away anytime soon and will be pretty key to 5G deployments. I'm sure my panel members will talk more about that as well going forward here. And of course, I want to just provide a little bit of a curmudgeon perspective on this. I am known at times to be a bit difficult in terms of the generational evolution of the networks. And so, I guess some maybe a cynical point of view, some of this, at least today, is a lot of lab trials are ongoing in terms of 5G work. But as I think we've seen in the past with some technology, it's, a lot of those trials do not translate directly into real world experiences, but we'll see on that. Maybe obviously the standards bodies are working pretty aggressively on moving towards some sort of outline for 5G. I know a lot of the marketing departments are getting out ahead of that maybe a bit, but obviously we have to let the standards bodies do their jobs out there. 4G LTE is working pretty well today. There are a few challenges here and there still, but I think most consumers are pretty happy with LTE and maybe just would like to see some enhancements there that could maybe provide some better services there. Again, there's always the marketing aspect of all of this in terms of all the different Gs. I think we've all seen the 2.5, 2.75, all the various Gs that were rolled out in terms of marketing or descriptions of various technologies. My thought is hopefully we can avoid that and just move to 5G, but that's obviously out of my control there. But again, from talking to a lot of the people on this topic, and again to our panel members as well, there are a lot of smart people working on what this move to 5G is going to be, and it does seem like that it will be a pretty impressive technology once it's all settled through. So I guess my only perspective or comment on that would be it will be glorious, but just give it some time to work through all of the trials and tribulations there, and we'll see some great networks going forward. So that's my quick run through there in terms of the topics on 5G. So with that, I will stop talking a bit, and we'll bring on Bill Ho from 556 Ventures to provide a bit of an analyst perspective on some of these 5G topics. So Bill, thanks for joining us today. We appreciate it.
Okay, great, thanks, Dan. Hey, welcome everybody. My opening remarks is that I agree with Dan's takeaway about the historical nature of the industry with marketing and hype and the need to talk about it at trade shows and media, the mainstream media, even on earnings calls. But to address a little more of how 5G relates to 4G, I think a lot of people are expecting it to be revolutionary, but I think everybody's positioning it as evolutionary. And, honestly, calling things revolutionary invites criticism and cynicism. But let's look at the 5G targets on the lower left-hand side of the chart here. It's set out by the ITU in its IMT 2020 vision that the industry is striving for. So by the way, 2020 is a targeted year when standards are finished. And for those who like to play mobile telecom trivia, 3G was IMT 2000 and 4G is known as IMT Advanced. So there's a lot of advance going on. So if one looks at the chart, we can see expectations for speed to increase greatly, latency to drop, and massive connection capability in orders of magnitude. So more importantly, what I didn't show was the spectrum and spectral efficiency, which I thought made the chart a little busier, but it increases, which will invariably, these increases will invariably lead to less expensive costs to deliver a bit, megabyte, gigabyte, whatever you want. This is important since we know that video today is a main driver for today and future data consumption. So on the surface, these things are foundationally exciting for current and new technical or business opportunities. And Dan also points out, rightly so, that there's a capital intensity for the operator community in deploying LTE. The big four operators have poured tens of billions of dollars, capital dollars, into their networks. But we know 5G is not a replacement network, but an overlay network. A lot of people have said that, much like when 4G was overlaid on 3G. But from the launch of 4G LTE at the end of 2010, carriers are moving to the next technical progression of LTE Advanced, or LTE-A. From the marketing side, we hear taglines like Sprint's LTE Plus, T-Mobile's wideband LTE, and Verizon's XLTE and LTE Advanced. But under the hood, there's the implementation of features and techniques like multi-band carrier aggregation, MIMO, and beamforming antennas. We know that AT&T and others have moved aggressively on the SDN and NFV bandwagon. So what's important is that these large expenditures aren't wasted and provides a foundation for 5G. So let's look at spectrum. So we know that there will be a need for new spectrum, not only because we've run out of traditional bands, but there's availability of underutilized higher bands. In today's world, we have been saying that Sprint's 2.5 gigahertz band is high band. In the 5G world, it's not. I think Guenther even joked that it's kind of low band. 5G will operate in under 5 gigahertz and in under 6 gigahertz and also greater than 6 gigahertz. How it will be used and will be decided by the operator and vendor community. But in contrast, the spectrum will have wider channels. What current services operate today is in anywhere from 80 to 100 megahertz in the market. In 5G, the pipe will be bigger in hundreds of megahertz or gigahertz. By the way, the spectrum graphic shows the bands under the global study for 5G. What won't change, as Dan pointed out, is the thorny aspect of global harmonization that ultimately will, for example, decrease complexity in devices and on the service level, roaming. Next slide.
All right.
So let's look at the motivations. Beyond the regular marketing hype, what are the motivations? Ideally, 5G will transform our lives, much like 3 and 4G are changing our own behaviors. Like today's voice calling has dropped off a cliff and data consumption isn't tethered to the desk, and how the choices we have on consuming linear and on-demand video content is a lot more on the screen through our hands rather than or on a tablet instead of just sitting down. So the cynic will say, with these motivations, it's about making more money, and I think there's a little bit of both, being idealistic and making money. Aside from the mobile community buying into 5G and new opportunities like an economic way to deliver fixed wireless services like HD, 4K, 8K videos, we have some players already dipping their toes in the water with 4G. I'm thinking the automotive industry, in connected cars, the energy sector in smart grids and smart homes and buildings, municipalities and governments in smart cities, which will include public safety. Augmented and virtual reality companies are just on training wheels. The players are trying things out, innovating, tossing out bad ideas and bad business models, and I see it as laying foundation for what 5G will become. So there's substantial money to be made outside what we know and have today. Within different global regions, there's a race to be number one or to be leading. For some, it's a matter of national pride, good for politics and public relations. We already see articles and declarations of which country consumes most data, which has the most data costs, and which country is the fastest mobile data in the world. But beyond that, new technology also delivers economic opportunity, growth, and progress. A couple of weeks ago, the EU President Guenther declared that the EU will be fully covered by 2025, 5 years after 5G standards are set. We all have heard the urgency of the Koreans and the Japanese to possibly have pre-commercial 5G demos and services for their Olympics. Others within the regions are working towards putting good technical and national PR for those other major global sporting events. Next slide. So this slide, I took a look at what operators are doing in testing and demos. For the most part, the more aggressive operators are already having some pre-5G equipment in their labs. I think a lot of them are, and have launched public demos and likely a lot more future field trials in the future. I scoured some 5G related press releases and distilled some key points in this table. And here are some of my observations. Speed in most cases tells a great PR story. Reaching gigabits per second says that they're at or really close to the 5G vision. In some cases, where the press release says they're getting closer to the 1 millisecond latency mark, and that's a big thing, I think. In spectrum, in all these PR releases says that 28 gigahertz is favored, while some have gone to 70 gigahertz or more. And I'm sure Guenther from Sprint can discuss his motivation for going that way. And finally, I want to highlight that SK Telecom, in what they tested in their base station is a handoff, which says to me that they're serious about mobile 5G and not just starting out with the fixed variety. So I'm sure that in the future, we're going to see more 5G press releases and associated marketing hype, whether it comes from the vendor community or the operators. But hype is part of this mobile game. It works, and I agree with Dan. It is glorious, and thanks for listening.
Very good. Thanks, Bill. Definitely appreciate it. I'm glad someone agrees with me on something. So always appreciate that. But again, I also want to remind those who are listening in that if you do have any questions as we go along here, to please use the questions tab there on the control panel and send those in, and we'll again be saving the last 15 minutes or so to get to some of those questions. So again, Bill, thanks so much for the insight there, and again, like I said, thanks for agreeing with me. It makes me feel good. But all right, so with that, we'll move on to bring on Ottendorfer, who's from Sprint, to get a bit of a carriage perspective on the 5G space. Guenther will start with a few slides giving some background on Sprint's work, and then we have a few questions as follow-up. So thanks, Guenther, for joining us. We appreciate it. Oop, did we lose? Is Guenther on mute? Oh, there we are. Now we can hear you.
Yeah, very good. So very happy to be here with you, and I'm very happy to talk about, and building on what Bill said, I think one of the things we think that is important for deploying 5G networks is you have to extend your toolbox already today. And certainly that's a road we have taken. We are talking about the densification and optimization of our network. That implies that we use different tools than in the past, where traditionally more voice-oriented networks have been built with a lot of macro sites. So what we do now is we deploy a lot of smaller solutions. We do deploy a lot of pole attachments and small cells. And that makes us ready for a 5G world. If we go to the next slide, you can also see that on this journey to 5G, we see what we do in the network today as building a foundation for 5G. We have, with our densification and optimization, the strategy of rolling out a very dense network. Those structures we use today for LTE and LTE+, but in the future, they will also be ready for 5G. As Bill mentioned, network function virtualization will be necessary in the core so that the wave of data growth can be handled. And it will be about high band spectrum. And we, as Bill pointed out, with our 2.5 gigahertz spectrum, today it's high band, tomorrow it will be the new low band. So that is something we do in preparation for 5G. For us, this journey about 5G is not, I guess, about the speed game, because it becomes increasingly less important for the customer whether you can offer him several hundred megabits per second or 1 or 2 gigabits per second. I think what will be important for 5G is the seamlessness of the integration between, on the one hand, the current technology, LTE, LTE+, and 5G, and it will be a seamlessness also for the user. What we mean and what we envision is that you, as a mobile customer, can seamlessly walk from your home to your car, to your work, and then to public venues, and you will always be best connected. That's what we expect 5G to do for us. And that's why we are excited about this journey for 5G. We have started this journey with the 2 demonstrations that have been mentioned before. The demonstration we did with Nokia on 73 gigahertz, where we showcased download speeds of more than 2 gigabits per second. We also did showcase with Ericsson on 15 gigahertz, similar download speeds, and in both cases, we reduced latency to below 2 milliseconds. As Bill said, this will be very important. Low latency is enabling the seamlessness I was talking about before. If you want really high quality, seamless streaming services in virtual reality, where you can turn your head and the landscape you are viewing in virtual reality seamlessly does the same with you, you need really low latency. That's why low latency is a key factor, and is probably much more important for 5G than highest throughput rates. So we have started that journey around the Copa America. We will continue to do that, and we see our LTE Plus network as building the foundation for this future in 5G.
Very good. We're going to definitely appreciate that insight there. And again, like you said, the description there kind of almost leads back to my initial comment there about the gloriousness of 5G. Again, when it's all seamless and working together, that'll be the panacea that I think we're all looking for in terms of 5G. But I guess I've got a couple of follow-up questions on that. I guess in terms of timing, I know there's been a lot of talk about the standards issue, and people are waiting for standards, and there's a 2020 and 2019 and various timeframes. I guess from your point of view, what's the timeline you guys are looking at in terms of standards and maybe even commercial availability of what 5G is to become?
Well, let me split the answer into 2 parts. One is, I would say the headline. The headline answer is we expect standards to be finished around 2018. We expect then commercial systems to be available around 2019, 2020. So that is the rough timeline. The reason why, and many people are talking about pulling standards forward. You had on one of your slides, Dan, that the standard work needs now to continue and settle things down. I think that's absolutely right, and I'll give you a few examples for that. So there is a high-level consensus around the waveform for the new radios, which should be CP-OFDM for frequencies of up to 40 gigahertz. The waveform for frequencies above 40 gigahertz hasn't been settled. The uplink waveform hasn't been settled yet. So there is a lot of debate around this, and I think those debates need to settle down. Recently in standardization, and we from Sprint are an active participator in 3GPP, there was adopted the OFDM numerology, and that is an important decision because it kind of invalidates a large part of previously published proprietary solutions. So it is important that the standardization process can now take its turn, really nail down the solutions. We also need to be aware that the first release, release 15, will be a very basic mobile broadband use case release. And I think release 16 will be much closer to a full release of 5G. So Standardization still needs the time. Proprietary solutions that are kind of talked about now have the risk that they will not become part of the future standard and then have a niche only have the possibility for niche deployments. And that, I think, is what we are seeing now in terms of standard development. And as I said, timeline for really commercial equipment in full functionality is around 2020.
Makes sense, makes sense. And again, I think you already kind of touched a bit on what Sprint's already doing today in terms of the work. I know you guys had the trials this year. I would just assume that you guys are, those trials are kind of an ongoing process for you guys, always kind of looking to see what's happening out there with your partners.
That's right. So for us, the work is split currently. On the one hand, in the work we do in the standardization, where we very actively participate in the working groups. And on the other hand, we did the trials. We are evaluating the results of the trials with our partners, Nokia and Ericsson, and we move forward and have ideas for further trials, because we tested, as you have heard before, in two spectrum bands, one rather low, 15 gigahertz, 73, a really high band. And that are the things, kind of practical tests we would like to continue.
Makes sense. All right. And then I guess maybe we'll go to that second question there first in terms of the spectrum part, since we're already kind of talking about that. Again, like you're saying, you guys are doing some trials already. Again, your 2.5 gigahertz spectrum, which I guess Bill mentioned, is kind of considered high band for traditional services, will be kind of low band. I guess, how important will all these various spectrum bands be in the standards process and the eventual rollout of these services?
I think it's a very good question. It is very important that the FCC really did, I think, a very important step by releasing the bands for 5G, the intended bands there. It is important for the operators to have kind of planning certainty around which bands are coming. Another thing that is very important, and we see it in other parts of the world, they push a lot for spectrum, which is not exactly millimetric, it's more centimetric, below 6 gigahertz. So that is something we are very aware of. And I think especially other parts of the world are pushing those solutions. So it is something that is quite interesting, and we will monitor and participate in that very carefully. And as you said, we have a lot of 2.5 spectrum. We expect that spectrum to work really well together with future 5G bands, because it will then become kind of the ubiquitous safety net for higher bands that have lower propagation and lower density. So when we go up above 20 gigahertz, we are talking about propagation of probably 100 to 200 meters. And that is important, that you then have a network that is capable of filling in those gaps. So the spectrum is really important, and we are very actively participating in that discussion.
Makes sense. I think maybe a final question there, I guess, is the use case aspect of this. I know that's always been a topic of discussion, is, I guess, the need for 5G. And it does seem like every day we're hearing new uses for 5G technology, whether it's IoT or connected cars or healthcare, various things like that. I guess, what's Sprint's view or your view on what are the maybe initial use cases that might drive these initial 5G deployments?
Well, initial use cases could be around, as you said, IoT, public safety, vehicle to network, those kind of things. But I think more important is the general idea. The way I see it, 5G is a world of new opportunities. New opportunities because of this lower latency that allows seamlessness. 5G could enable things and ideas that have been considered in the past but were not viable. And these ideas will probably allow new kinds of user experiences on the network. The way we think about it is it's a little bit like Star Trek. If you envision that you are Captain Kirk and you can interact seamlessly with your environment on board of the USS Enterprise, he was able to use things like universal translator, communicate seamlessly between the bridge, different parts of the ship, transporters, etc. that's what we see in this world of opportunities of 5G. And not everything has been defined. It will develop as we get closer to it. And I think a lot of it will be driven by the low latency capability that comes with 5G.
That makes sense. Well, again, a great reference there to start check. We always appreciate keeping it real like that. So thanks, Guenther, for the great insight on that. We definitely appreciate that from you. And again, we'll have Guenther as part of our Q&A session here a little bit later on in the webinar, as well as Bill from 556 Ventures. So for those who are listening in, if you do have any questions for our panel members, like I said earlier, please feel free to use the questions tab there on the control panel and send those in, and we'll be trying to get to those a little bit later on in the webinar. But Guenther, again, thanks so much for the time. We appreciate the insight there. So with that, I want to now bring on Mike Murphy from Nokia to provide a quick overview from Nokia on the topic. So Mike, thanks for joining us. And also, let me see, I want to give Mike some extra attention because during the recent CCA show in Seattle, Mike was on a panel with some other vendors and provided some great insight as well as a bit of a reality to the 5G discussion that almost melted my cynical heart. So thanks, Mike, for that. But again, Mike Murphy from Nokia, thanks for joining us. We appreciate it.
Sure, my pleasure. Thanks, Kyle. So we'll go next chart, please. So from a vendor perspective, we're seeing a lot of engagement in 5G. You know, the headline projects are fixed wireless in the US and the Olympics in Japan and Korea, but really it's a global play. And you might say, well, you know, that happens with every generation, but I think the difference here is twofold. One is that things are happening far, far in advance of the standardization completion. So, you know, as Guenther mentioned, you know, we only see standards completing towards the end of 19, but we're already talking about large-scale trials and even commercialization in 2017. And then the second difference is that there's new players entering the fray. So we starting to get some interest from cable operators, from some of the over-the-tops, and even from some Wi-Fi operators. So that's the difference in 3G. I think it actually is, or 5G rather, it actually is different from other generations.
Got it.
Next chart. Yep. So access gets a lot of the attention, of course, these days, but 5G is more than just access. So there's a new access type, of course, but there's a highly optimized core, both to support the new access types, plus provide some increased efficiency for different use cases. And often forgotten is the changes required in the transport network. So we see a lot of change required architecturally there, both to meet the capacity and latency demands of 5G. And I think, you know, having a complete portfolio really helps make the solution better here. And so in our case, thanks to our acquisition of Alcatel-Lucent, I think we're in a good position there.
Very good.
Next chart. Yeah, I know Dan didn't like the many names of these from 4 through 5, and you know, we're guilty of that as well, introducing a few names here. But I think the more important part is that what I like to say is that you know, you got to get your engines running for 5G. The time to start is now, but there's still a lot of gas left in the tank for 4G. So we still have some good steps to go through in 4G. And one thing that I like to say is that you know, maybe the best 5G network is a great 4G network, because you want the delta between the two to be as seamless as possible. And thanks to some of the new technology steps coming up, we're able to do that going forward.
All right.
Next slide. Yeah, so on the architectural changes, I think this is worth spending you know, a minute on or so here. So we see that you know, everything will become virtualized, including the RAN. And what that means somewhat is that the RAN moves a little more towards the center, and that the core moves a little bit towards the edge to be able to hit those latency targets. So the end result is you end up creating something called edge clouds. And this is a significant architectural shift in 5G. And that's why I said, you know, it's not only about access and core, it's also about the transmission network that you need to support 5G. So that's a very short summary. I know we were asking for to keep it short there, Kyle, so I hope I've done so.
That's perfect. I definitely appreciate it. Thanks so much, Mike, for that. Great insight there. And again, Mike will be part of the discussion here in a little bit. So if you got any questions for the panel members, please feel free to send those in, and we'll get to those in a little bit. So with that, now I want to bring on Durga Malati from Qualcomm for a little perspective on the new radio angle as well. So Durga, thanks for joining us. And I'll also mention too that we did have a longer video interview with Durga from the recent CTIA show that I believe might be on our website here shortly. So if you want some more insight from Durga and from Qualcomm, you can make sure to check that out as well. But Durga, thanks for joining us. We appreciate it.
Thanks, Dan, and good to be here. And let's skip to the next slide, and let's talk a little bit about. There's a lot of background that has already been given by the previous speakers, and from our standpoint, designing the new radio needs to, or NR as it is called in the 3GPP terminology, needs to take into account both foreseen and unforeseen applications, and we are designing some sort of a system for the next 10 years and even beyond. And in that sense, we had to be very careful about the choice of the waveform, and we specifically chose OFDM-based waveform as the solution for 5G. And in that sense, it's the first time we are doing a G transition wherein we are not effectively changing the waveform itself. So 1G to 2G, we went from analog to digital, we went from TDMA to CDMA in the 3G transition, and OFDM came in the 4G transition. But it's the first time we are actually not changing the essentials of the waveform per se. We still believe in the cyclic prefix-based OFDM and variants of that in terms of the single carrier waveform from an uplink standpoint. And perhaps for the much higher bands above 40 gigahertz, Guenther mentioned it earlier, there are some nice properties of using single carrier structure, but effectively it's an OFDM waveform. And the question is why? Why OFDM? Wasn't there really nothing else that's left? The truth of the matter is that OFDM is a really efficient waveform in terms of the ability to scale appropriately, both in time and frequency. And what that means is as we go from the smaller bandwidths to the much larger bandwidths, we can scale effectively. And as we increase the tone spacing, we can also scale in time, as in shrink in time and expand in bandwidth. That's one important property that we're going to be utilizing quite extensively in 5G NR. And the other one is the ability to multiplex different kinds of services with different QoS requirements in an efficient way in a single unified air interface. And that's the key part. We are dealing with a large number of diverse services ranging from mobile broadband, which go to very high data rates, tens of gigabits per second, low latencies of less than 1 millisecond, end-to-end turnaround time, and massive IoE services, which rely a lot more on scalability and the ability to get into the system and out of the system quickly enough, but at the same time focus on low power. So OFDM-based waveform is the default choice, and that's not just our proposal, but there's also an emerging industry consensus that that seems to be the right choice. And in 3GPP, cyclic prefix-based OFDM has already been chosen. Let's go to the next slide. So speaking a little bit more about scalability, this is the one chart which is a catch-all in terms of the kinds of requirements that we are talking of. From day one, we want to multiplex all sorts of services and spectrum types. Both licensed and unlicensed from day one, TDD and FTD services. But if we actually were to take a look at the different kinds of QoS requirements, on one hand, we take a look at the mobile broadband area where we really focus on extremely high data rates, higher order modulations, massive MIMO operation to be able to multiplex larger number of users in spatial domain, so usage of multi-user MIMO, which leads to a much higher capacity on a given geographical area. So it's both an average and peak rate argument from a user standpoint. So if you have a device which is operating in a 5G network, then you get a much better average rate as well. But from a network standpoint, it's a much higher capacity in a given geographical area. These are kind of important aspects. As we move into the Internet of Things, the point that needs to be made is that we've taken a pretty good stab at Internet of Things already starting in 4G with enhanced machine type communication, EMTC, and narrowband IoT. The key is to now take it to one additional level beyond it, where we want to allow for an extremely large number of nodes to be served in an IoE service. So that's why we call it as a massive IoE. It's not just regular IoE, which leads to a network which is more geared towards multiplexing such number of devices, cleaner signaling architectures, and the usage of mesh architecture to have much deeper penetration and reducing penetration in terms of the link budget that we can support for these devices, while keeping them low cost. That means that even the transmit power could be much lower than where we are today. And as we go further into IoE, and there is a different kind of IoE services, and they therefore merit like a different QoS category, and that would be what we call as mission critical services. Again, it's a well-known term in the industry right now, but just to give you the sense of it, here the focus is not about the high data rates, it's not really about even the scalability part of it, but the real focus is on making sure that packets are received end-to-end in a much lower time scale latency than before, and in a far more reliable manner. Typically, when we rely upon these sorts of things, as if something needs to be very reliable, we tend to rely on retransmissions, and multiple techniques are used in that. But this is one of those instances wherein we might not have enough time for retransmissions, but at the same time, a packet needs to be received less than 1 millisecond. So different techniques of how do you multiplex this service. And an example of multiplexing this service of mission critical services, mobile broadband, is if a network is already serving some existing users and all of a sudden there is a mission critical packet that needs to be sent out, well, you actually have to send it immediately. You can't wait for the existing transmission to complete. So you have to send it immediately, but at the same time, make sure that you're not disrupting the existing services. So there's a seamless way of operation. So these are the key parts of the new radio waveform that we're working on and the industry is looking at. Next slide, please. Okay, this is a far more busy slide, but it actually gets to the gist of the number of topics that are there in 5G NR that we are dealing with. At this point in time, the ambitions that we have for 5G NR are very lofty. Some of these have already started off in 4G, but a lot of them are actually going to mature only in the 5G domain. On one hand, we have new shared spectrum paradigms, which goes beyond what we are talking of in the traditional listen before talk techniques for unlicensed, but we are trying to look at even more fundamental shifts in how we share spectrum appropriately. In the US, we've already taken an initial stab at it, at how things are happening in 3.5 gigahertz, and with the new bands coming out in the 37 to 37.6, which is also shared spectrum, and beyond that in the 60 gigahertz, that's also shared spectrum. So we're kind of looking at that. Integrated backhaul and access, and is perhaps a key component of 5G. A lot of the use cases that are emerging relate to fixed wireless backhaul. But speaking about that, as we look into what sort of spectrum and what kind of spectrum and which bands are being used for this, millimeter wave is a very important band, the way we see it. On one hand, it's not new. There are plenty of fixed wireless backhaul solutions today that already use these high bands. The key from our standpoint is to make sure that the system is a mobile system. So making a millimeter wave system into an effective mobile system so that we can employ millimeter wave in devices, that's really the key argument here. So this entails the usage of fast analog beamforming and beam tracking techniques, the ability to use this sort of a system in a non-line of sight environment, when you have hand blocking and head blocking on a device, and making sure that these devices are power efficient. That's really the focus of millimeter wave from our standpoint. And as we further go into the rest of the applications, I'm not going to actually talk about all of that. These slides are going to be available later, but there's a couple of things that I wanted to mention. And one is vehicular communications. We haven't touched upon it a whole lot, but we're starting the idea of using vehicle to network, vehicle to vehicle, vehicle to infrastructure. And when we say infrastructure, this would mean traffic lights, stop signs, and so on. These communication systems are being designed. We're actually starting that in 3GPP as such. But the requirements that are needed to make these systems work are being addressed and looked at from a 5G NR design standpoint. So it's kind of an important part. Let's skip to the next slide from here.
Okay.
All right, so this would be the last slide that I have. And from our standpoint in Qualcomm, we are really in favor of accelerating the overall 5G NR path. As was mentioned before, this is a unique time where standards process is occurring in parallel with the prototype development and pre-commercial testing. So it's a very exciting time to be from a 5G standpoint. We want to make sure that 5G delivers everything that is actually being promised. We've got to actually test it and prove to ourselves first, prove to our customers, and as an ecosystem, we owe it to ourselves to make sure that it works properly. And with that thought, we introduced our 5G prototype testbed and systems, which actually not just test the technology that we are proposing into the standards process, but also factor in the decisions that are made in the standards process so that these prototypes are available for interoperable trials and interop testing activities so our customers can see it work in the right way. We're pretty active in the standards process. Our team actually is quite, there's a large team that actually goes to 3GPP. It's a pretty large ecosystem at this point in time. Our hope is that as we do these prototypes and work with our industry partners, we can do impactful trials and test out all the early deployment, all the kinks that are left over there to make sure that the system works properly. And as I mentioned before, it's not just about the air interface. It's an entire ecosystem that needs to work the right way with both modem and RF front-end leadership that is needed to make sure that 5G works properly. Thanks.
Well, great. Well, thanks, Durga. Definitely appreciate the insight there. And Durga will also be part of our Q&A at the end there, but we appreciate that, Durga. And now batting cleanup for us will be Ian Wong from National Instruments. Ian, thanks for joining us. And I guess we're ready for the slides there.
Yeah, thank you. And it's an honor to be here. We've talked about, I mean, the previous panelists have talked about this, the three major application thrusts for 5G, enhanced mobile broadband of really peak rates, the massive machine type communication, Durga talked about that quite a bit, and low latency communication. So we at NI, if you go to the next slide, I mean, we've been working on 5G for quite a while. We have basically, like, there's a lot of technologies that are being talked about, but we have internally have focused around 4 key areas. The first one is massive MIMO. So we believe this will be a key technology for 5G, and Durga has also mentioned that in a few other panelists. Basically, the idea here is to put tons of antennas on the base station, a lot bigger than what we have in terms of 4 and 8 right now. We're talking about 64 to 128 antennas or even beyond, so that you can really exploit the degrees of freedom in the channel and use multi-user MIMO to improve the spectral efficiency. So this primarily is a technology for below 6 gigahertz, wherein we really want to extract as much value as we can from that low and very valuable spectrum. Speaking about spectrum, though, the next frontier really here is using millimeter wave, which is going high, going wide, you know, ability to achieve up to 1 to 2 gigahertz of bandwidth. And that's how we will get both our massive broadband for the eMBB use case, but also the lower latency aspects of it. Like a lot of the trials that Nokia and Sprint have talking about, this is the focus, you know, going up to 28 to 39 to 60 and beyond, you know, that's 60 is unlicensed, and 72 for E-band. The third technology area that we've focused on a lot is actually trying to exploit the multiple physical layers that have been developed in the various standards, and kind of call it under multi-RAT. And basically, this is where we want to evolve the physical layer, and a lot of new waveforms have been proposed. This has been whittled down to CPO-FDM in the first phase of new radio for below 40 gigahertz. But there are a lot of other techniques still that are valuable that can be made on top of OFDM, like single carrier techniques and so on, especially for above 40 gigahertz. And finally, we didn't touch upon this too much, but really at the end of the day, it's about transforming the whole network. And I think a couple of panelists have mentioned this, like all the way from the core network down to the transport and kind of figuring out what is the best way to do this. So from that perspective at NI, I mean, we're not only thinking or talking about this, and if you go to the next slide, we actually have commercially available platforms for researchers and scientists and vendors to use today. So Durga has mentioned the importance of being able to prototype these things early to make sure that this works, and we owe it to the ecosystem, we owe it to the industry to do that. And I think the key difference that NI brings to the table is we actually make these prototypes available for everybody that wants to use it, all the way from academic researchers to network researchers that want to take our hardware and software and prototype these systems. You know, they're ready to run and available, and it allows us to accelerate really the innovation in this area. And going to the next slide, a few use cases and a few kind of the success stories we've had. I don't know if you've all seen this, but basically a couple of our universities in Europe, a couple of our lead users, Bristol and Lund, smashed the world record for spectral efficiency recently by using techniques in massive MIMO. So this is, I would call this the true spirit of massive MIMO envisioned by Tom Marzetta, wherein they were able to achieve 145 bits per second per hertz when LTE is a peak of about 16 right now, with a 128 antenna system and 22 users simultaneously using the time frequency resources. And this is all done using our software-defined radios and LabVIEW. And go to the next slide, one of our key partners as well as Nokia, who have been using our platform for millimeter wave to kind of smash one peak rate record in a very short time frame. So from Brooklyn Summit in 2014 all the way to 14.5 gigabits per second in Mobile World Congress in 2016, kind of showing the value of using an open platform that a broad ecosystem from academic researchers to industry researchers can use this platform to again accelerate the pace of innovation and discovery for 5G.
Very good.
So that's it. Tried to keep it short.
You did great. Thanks so much, Ian. I definitely appreciate it. Again, a lot of good, interesting information on the topic there. I think if we could do a 2-hour webinar, that might be a better way to go with this. But definitely appreciate everybody's insight there. And with that, I want to go to kind of the Q&A section here. We got quite a few questions in. I know Bill has been very busy there answering a lot of these questions. So Bill, I appreciate you taking charge of some of those. But maybe for Bill, maybe one of the questions that still up there, and in terms, I guess, of the use cases in terms of machine to machine, and someone's asking, how will 5G be used in MTM communications, inside venues and manufacturing plants and in buildings? I guess, and also about the service providers involved in that. So I guess, do you have any insight in terms of how you view how the I guess telecom community might approach kind of maybe some of these more localized deployments of kind of 5G in terms of the enterprises that they might need?
Yeah, so I think the key is every operator's motivation is to make money and to provide connectivity and management. So that's, I think, in a nutshell, how they'll participate in it. So it's not only about the connectivity, but it's also the back end stuff of integrating various systems for the for the manufacturing plant, for the enterprise who have this interest. So I think the playbook is very similar in that it just moves on to an evolutionary role to the next iteration, but with more and more enhanced features so that the enterprises will benefit.
Makes sense. Sounds good. Very good. Appreciate that, Bill. We've got a question here for Guenther. We actually got quite a few for Guenther, but I'll pick one here off the top. And someone was asking about, I think it was your trials that you guys had recently with Nokia and Ericsson, and talking a bit about the latency aspect of that, the low latency. Someone's asking which waveform was used for those trials. I don't know if Guenther, if you have any insight into what was used for those trials.
I would need to double check, but I think it was CP-OFDM, so it's a cyclic prefix OFDM. But I would need to double check with the test team, but that would be my guess. Okay,
very good. No problem there. I'm going to quickly run through as many of these as possible. So I'll pick the most questions that have the shortest looking answers at least. So maybe next question here, maybe we'll bring Mike on for this one to kind of get some insight. Someone's asking, maybe what's the major factor to impact latency with today's 4G network? So maybe Mike, from your point of view, what is, I guess, the biggest hang up with the current LTE deployments out there?
Okay, so in 5G, there's kind of two latency targets. One is for the access and one is end-to-end. The access side is a very famous 1 millisecond. End-to-end, less talked about, is 5. And what affects on the access side perhaps the most is the TTI, which is 1 millisecond in LTE. So one of the biggest changes in 5G is to reduce the TTI down to 200 microseconds or so. And then there's a myriad of other things that play a role in that. On the end-to-end, there's also elements of standardization, but there's also elements of just how you design your network. So you need to architect your transport network, for example, to be able to support low latencies like that. So just as an example, in the access side, that may imply dark fiber, for example, depending on your architecture there. So the consideration, there's an element that comes in the standard, and there's an element that comes in the actual implementation too.
Got it. And maybe to tackle one quick one, a follow-up for that one, Mike, for you is, I guess, is that 1 millisecond, a goal? Is that an achievable goal, I guess, in terms of what we could do for 5G?
Yes, absolutely. It's achievable. I mean, in our demo systems today, our proof of concepts and moving into trials now, we're at that already.
That makes sense. Okay, very good, perfect. Another question here, I'll direct this one towards Durga. Someone's asking, I guess in terms of the handoff integration, it says, will 5G have better seamless integration handoff with Wi-Fi? Or is it already sufficiently good with LTE? I know Qualcomm's been working quite a bit in terms of kind of working with the unlicensed spectrum as well. So maybe, Durga, from your point of view, is that going to be one of the main maybe benefits of 5G is just a better integration overall with kind of the Wi-Fi network out there today?
Well, in general, I think from a 5G standpoint, what we're looking at is not just Wi-Fi, but multiplexing several radios in a multi-connected device, but then making sure that the services go back and forth between any kind of a radio, depending upon what is needed at a given point in time. So unlicensed is being embraced from day one in 5G, and that's just a natural part of it. But speaking a little bit more about the way you would do a handover of services, there's no strict handover per se. It's really more about mapping of different bearers or services into different radios. So there's something known as a separation of the control and user plane, which is kind of a fundamental way of thinking about the way things are coming up in 5G. What it really means is that one can allow for some sort of an anchor which happens to be in one radio, and you might have the services coming up on other radios, and these services get mapped back and forth between a multitude of radios that are available. So at one point in time, you might be served using a millimeter wave access point. At a different point in time, it might be coming through a Wi-Fi access point, and at the third point in time, it might be coming through an LTE-based station which contains unlicensed or some other licensed spectrum. So it's more a matter of how these services get mapped, and the whole idea of handover, there's a little bit of rethinking over there. It's more about services going seamlessly between different radios as opposed to a physical movement from one base station to another of a connection.
Very good. Okay, that sounds great. Appreciate that there. And maybe for Ian, I got a question here. I think it's looking more at the, transmission using millimeter wave spectrum. Someone's asking, will line of sight be required for a millimeter wave spectrum? I don't know, in the work you guys have done there at NI, I guess what's the view in terms of being able to, get the millimeter wave spectrum to kind of, adapt to different environments? What's the view on how that'll be used in terms of those deployment models?
Right. So actually that is actually a popular myth that millimeter wave needs line of sight. So we've had some trials, and our partners at NYU Poly with Ted Rappaport have also done some investigations that definitely in certain surfaces, it can go actually around corners. And however, that being said, it won't be as, let's say, penetrable as in the lower frequencies. So a lot of the techniques like a fast beam steering and potentially, the techniques used in 4G like comp, like multiple base station cooperating. So those will be key to really make millimeter wave successful in the mobile space. But it really, it doesn't need line of sight. It can work without line of sight.
Got it. Perfect. All right. And then another question here, maybe for Guenther. Someone's asking a bit about in terms of the backhaul issues for 5G. I know Sprint has some history in terms of using microwave. I think you mentioned that a little bit earlier as well. But I guess how does Sprint, approach the backhaul issue when it comes to these 5G networks? Because it does seem like to achieve those low latencies, it will be pretty important to have some pretty robust networks in place to handle kind of the backhaul aspects of this.
Yeah, that is a very good question. And our answer to that question is we will use a combination out of different technologies. So traditionally, our network has been very much Ethernet-based. We have also fiber. We will roll out that fiber further to aggregation sites. And then from those aggregation sites, we'll have also microwave. And that should give us the capability of rolling out very fast, because the speed of rollout is important, but then also have the capacity you need. Because nowadays, and that's different to 10, 15 years ago, there is very low latency, high capacity microwave available. And that's what we will be using, but it will be a mix of technology, mainly fiber and microwave.
That sounds great. I think we have time for one more question here, and I'll bring Bill on for this last one here. Someone was asking about obviously the densification issues when it comes to 5G. I think everybody's, we've heard the numbers of we're going to need millions and millions and billions of new, cell sites or transmission points for this, I guess. And obviously there's complexity in doing that. I guess what's maybe the general overall view from maybe an analyst perspective on how the market will kind of tackle the siting issue for this, because it does seem like even today, even with the hundreds of thousands of sites we have, getting new ones up is pretty complex. I guess looking towards is having millions of sites up there. I guess what's the view on the ability for the industry to tackle that aspect of this?
I'll point out that it's probably a very tough issue that probably a lot of the participants can kind of talk about. But I note that I think at CTIA or at CCA, where Tom Wheeler, the FCC chair, mentioned that the commission will look at kind of addressing the not in my neighborhood issue, which is probably a thorn in the side of densification. So at least you have a governmental force that's on the lookout for that to help the industry.
Yeah, that's a good point.
Sorry, and then probably from my side to add to that, I think the Commission, FCC, has already been very active. They recently, I think in August this year, made an agreement where they made the deployment of small cells a lot easier, an agreement with the Preservation Office. So they are really taking active steps in allowing an efficient rollout of 5G infrastructure.
That sounds great. Well, I got more questions today, but we're out of time. Well, I think with that, I don't want to get into another question here and not be able to finish it. But I will say thanks again for everyone for sending those questions in. And sorry we didn't get to all of those, but we will be sharing a list of questions with our panel members who, if time allows, can follow up individually on those questions as well. But definitely appreciate all those questions that were sent in on this. Also, let everybody know this webinar will be archived on the rcrwireless.com site in a few days for those that might have missed some of it. And please make sure to check out our feature report on the topic as well. That should be available on our site here shortly. And again, I want to thank our great panel members. I have to say personally, it's one of our better webinars in terms of panel participation. So we definitely appreciate. Thanks so much to Bill, Guenther, Michael, Durga, and Ian for providing great insight. Thanks so much, guys, for your help today and insight. And thanks a lot to everyone. And have a good afternoon.